This video is part 1 of a 2-part series, made in collaboration with Explain Something. Check out part 2 in the description, as well as Explain Something's YouTube channel for more videos like this one. Most of the atoms in your body are 13.7 billion years old, and being you is just the latest page in the incredible story of their lives. We know for sure that they've been inside of stars and floated suspended in outer space for far longer than our species has been around. They've washed through the chemical cycles of the Earth countless times, which might have included being frozen to the top of a mountain in one eon, to stomping through the dense jungles as part of the thigh bone of a brontosaurus in the next. We can use modern science to see the story of us from its true beginning. Along the way, we'll discover how we are born from the universe, not separate, like a wave that emerges from an ocean. Atoms are the minuscule Lego blocks of everything that we see around us. They make up the cells that make up our bodies, and most atoms will journey around the universe for 10 million, billion years before they break down. They are practically immortal. Though there are different types of atoms, called elements, with slightly different but parallel origin stories, they all begin in the same place, the Big Bang. To find out where their story starts, the lens that we have to use is a field of science called astrochemistry, which is the study of atoms and molecules in the universe. While the nature of the Big Bang itself remains one of the greatest unsolved mysteries in science, we do have a good grasp on what happened immediately afterwards. From a microscopic point, the universe erupted outwards in a condition of unimaginable heat and pressure. From the sheer amount of energy coursing through the fabric of reality, the first quarks seared into existence like waves erupting from a turbulent ocean. Within minutes, quarks joined together to form protons and neutrons. They formed an opaque cloud of plasma, so vast that it stretched across the new universe. It rippled with light and electricity, and it might have looked something like a combination of being in a plasma globe and the most intense lightning storm of all time. The universe passed 240,000 years in this dense and violent plasma storm, a time so long on human timescales that it would have encompassed the entire history of our species. But the same explosive force of the Big Bang that created the plasma storm kept the universe expanding, and eventually it started to cool off. The electricity which rippled through the cloud began to combine with its protons and neutrons to form the transparent gases, hydrogen and helium, and thus the first complete atoms to exist in our new. 90% of the atoms in our bodies directly come from this hydrogen and helium. The plasma storm eventually began to fade and was replaced by these clouds of these new transparent gases, and the universe began to resemble space as we now know it. In the cold silence of space, your atoms would have been witness to one of the most sublime visions in the universe, the formation of the Milky Way galaxy through the veil of a nebula. At this point, the remaining 40% of your atoms began to diverge from hydrogen and helium. They started to feel the pull of gravitation, first subtly and slowly, but soon like a colossal riptide. They were pulled into the gravity well of a still-forming giant star, one of the ancestors of our Sun. As more material fell into the growing star, the pressure felt by your atoms climbed to over 250 billion times the pressure of our atmosphere. A dull glow began as the star ignited, which soon became a heat and light hotter and brighter than anything that we could imagine. Your atoms spent hundreds of millions of years here, adrift in the ebb and flow of the internal storms of the star. Some fell deep into the star's core. Here they were subject to pressure that was extreme compared even to the rest of the star, and in this furnace, atoms of hydrogen and helium fused together to become oxygen, carbon, iron, and other elements. Releasing bursts of heat and light as they merged. In the present day, the light from the sun that warms your skin and the flickering of light from the stars at night originates from the same brutal process of fusion. After 3 to 4 million years, the giant star began to run out of hydrogen and helium fuel in its core. At the same time, the waste products of oxygen, carbon, and iron began to build up, and its light dimmed. It erupted in a supernova explosion, a blast so violent that it would have been visible across the other side of the Milky Way galaxy, if there was anyone there to see it. The searing explosion fused other atoms, creating more oxygen and carbon, as well as rarer elements like silicon, chlorine, and sodium. The shockwave pushed newly formed elements back into what was left of the original hydrogen and helium cloud, disrupting it and seeding it with countless new atoms. As the shockwave impacted the surrounding gas, it compressed millions of miles of hydrogen and oxygen together to form icy water. Disrupted from the blast, the gas cloud began to once again feel the pull of gravitation. But this time, it was full of ice and new rocky elements, which clumped together and grew larger and larger. From the cloud, hundreds of new, smaller stars were forming, and possibly planets too. This cycle of the birth and death of stars and planets repeated a number of times, until eventually one of the new stars was our Sun. In the small part of the cloud that our Sun occupied, most of the remaining hydrogen, helium, and now other elements too were once again captured by gravity and were descended to be set adrift in the internal stellar storms all over again. But some of the gas and rocks found themselves not being pulled into the Sun, but held in orbit in a vast ring around it called an accretion disk. Over time, they collided with each other, forming larger and larger asteroids in a series of impacts, until they grew to the size of planets, which were bombarded by asteroids for hundreds of millions of years. When it ignited, the Sun released a series of immense shockwaves that impacted the new planets and determined the shape of the new solar system. It pushed most of the gas outwards towards the outer planets, where it formed the gas giants Jupiter, Saturn, Neptune, and Uranus. The heavy, rocky material that was closest to the Sun was left behind by the shockwave, and it formed the small, rocky planets Mercury, Venus, Earth, and Mars, with a thin remnant of gassy atmosphere for each of them. One of the main scientific goals of missions that we send to the Moon and to Mars is to gather and analyze their soil in order to discover the composition of the accretion disk that formed the planets. Information like this helps us determine if the conditions on Earth are in some way unique, and if this could account for why there is life here. As it turns out, if there's something unique about the Earth, it's not in the soil. Over time, the asteroid bombardment slowed down, and the atoms that would eventually form you found themselves all in one place. In part 2 of this series, we'll look at what happened to your atoms after they fell to the Earth 4 billion years ago, and where they'll end up when the Earth is gone. Link is in the description.